Okay, this is going to be uh, the review for the test on Tuesday. This is the history and atomic structure test review. That's me, Mr. J, and what we're going to do is, or hopefully what we'll get done today is answer a few questions, maybe clear some things up for you. Let's start with the first one here and look at number one. What is the name of the isotope with 6 protons and 8 neutrons? So we already know that this number is the atomic number here, right? We all know that. And when you add the protons and neutrons together, so you have 6 protons and you have 8 neutrons, that is the mass number, okay? And so what you get from that is you get 14. So we also know that number 6 on the periodic table happens to be carbon, and so that would be carbon 14. But we can also write it this way. Um, That is the hyphenated notation there. But when you put it in the nuclear notation or the uh, isotopic notation, we're going to write our symbol. And I'll put this in red. We're going to write our symbol. We're going to write the atomic number at the bottom, the mass number at the top. And that's another way of writing carbon 14. And there's no charge to that, so we don't have a superscript of a +1 or a -1 or anything. So the charge on this, the net charge, is going to be 0. Okay. However, if you look at number 2, um, it says if potassium has a charge of +1, it is now called what? Well, that means it's a positive ion, and if it's a positive ion, that would be called a cation. Okay. A negative ion is called an anion. All right. Those kinds of things are going to be on your test. This didn't show up so well on number 3. I have to rewrite this, so I'm going to rewrite it for you right now in red. Magnesium with a +2 charge. 24 is the mass number, and the atomic number is number 12, which now we can easily give the PEN. So if we look at that, the number of protons is going to equal 12. Okay. The number of electrons is going to be 10. And the reason why it's 10 is because if you look right over here, that shows me I have 2 more protons than electrons. Okay? Which also says that we have 2 less electrons than protons. So that's why the electron count is 10. And then, lastly, for the number of neutrons, we simply just subtract the 24 and the 12, and that will give us 12 neutrons for that problem there. So for your answer, we have 12 protons, we have 10 electrons, and we have 12 neutrons. Okay? So another part of your test is going to be um, the scientists. So we want to look at who did what um, for each contribution to atomic theory. If you look at number 4, discovering the positively charged nucleus using the gold foil experiment was from this scientist. Uh, that one is Mr. Rutherford. Okay, gold foil experiment and the positively charged nucleus. Those are key things, key concepts for scientists. Coining the word atom, Democritus. Okay. The scientist that developed the planetary model of the atom in number 7, that would be Mr. Bohr. Okay. All matter is composed of atoms, and that all atoms of an element are alike, that is Dalton. The plum pudding model, cathode ray tubes, um, Thomson. Thomson. Plum pudding model. Okay, so make sure you understand what scientists did what. Those are very, very important for Tuesday. How does an atom become an anion? Well, to become an anion, you have to become more negative. And when you become more negative, that means you gain electrons. We don't lose protons. We don't gain protons. We only gain and lose electrons, but you gain electrons to become an anion. The atomic number for an element is the number of protons that are found in the nucleus. The nucleus. Hope you can read that writing. So we know that protons are found in the nucleus of an atom, but we also know that neutrons are found in the nucleus of an atom as well. Okay. We just have a few more questions to look at. It's not a super huge review. Oxygen 16 is different from oxygen 18 because, well, first of all, they're both oxygen, of course, and that means that the number of protons are the same. Okay? The number of protons are the same. So the only thing that's different is you have to remember that this number here is the mass number, and that is the number of protons plus the number of neutrons. And so the only thing that can be different is the number of neutrons. Okay? And that's what an isotope is. The number of neutrons are different in the nucleus, but the number of protons stay the same. If you change the number of protons in the nucleus, then you have a different element altogether. Okay? And you're going to see this a few times on the test also. Isotopes of silicon, or average atomic mass, I should say. So we're trying to calculate average atomic mass for these three isotopes of silicon. And you're not going to have the same problem on the test. You're going to have a couple other ones. And you're also going to have a table as well that we've practiced before. So let's take a look at this. So we have our silicon 28. I'm going to write it that way. And then we have our silicon 29. And we've got our silicon 30 here. So this is a really easy thing to do. The average atomic mass, and this is the equation for it, is the percent abundance that's a C, multiplied by the atomic mass. And when you do this for all three elements, then what you're doing is adding them together. But the first thing you've got to do, and you can do it a couple different ways, but the way that I would like you to do it is move the decimal point a couple spaces. But if you're not comfortable with that, we'll do it a different way. So here we go. So silicon 28, the percent abundance is 92.23. So we're going to write 92.23%. Okay, and put it like that. And we're going to divide that by 100. Then we're going to multiply to that the atomic mass, which is 27.97693. And we're going to get an answer for that. And when we have two other isotopes, we have to add to that for silicon 29, the percent abundance, which is 4.68%. And we're going to divide that by 100 and multiply it by its atomic mass, which is 28.97649. And then we're going to add to that the third isotope, silicon 30. And silicon 30's percent abundance is 3.09%. Divide that by 100. Multiply that by 29.97377. And when you do that, when you add all of these numbers together, okay, we're going to add the first one, second one, and the third one, you're going to come out with a really nice answer, and its unit is going to be in AMUs. Okay? And I think, yeah, that's it for the review. If you have any questions about this stuff before Tuesday, send me an email, comment on this, and I'll get back to you as quickly as I can. Have a great day.